Okay, here we're going to take a look at the second half of your review. So for learning target 7, we are calculating the proportion of things. What percent of our distribution fulfills this requirement? And so here for A, we're asking what proportion of runners have body weights below 60 kilograms. And so here we're using the normal CDF thing on your calculator. So if you forgot, it's second vars, and then go down to number 2, that's normal CDF. And there's 4 things that we need to enter. First thing is we want the lower bound, and so if we want below 60 kilograms, well, we're going to want to go pretty far. 0, it'd be tough to have a weight less than 0. So 0 is the lower bound. The upper bound would be 60. That's as high as we want it to go if we want everything below 60 kilograms. And then we put the mean, which we saw on the last page, 63.1, and the standard deviation, 4.8. And when we do this, we get 0.259. And so again, the important thing is, what does that mean? You need to write that out. And that means that 25.9% of the distribution of the runners have weights that are below. For part B, we are talking about the proportion of runners that have weights above 60 kilograms. And so our lower bound this time is 70. The upper bound, 1,000. I think Jeff should probably cover it. And then again, mean, 63.1, and standard deviation. And the number that we get when we spit this out is 0.075, which means 7.5% of the runners have weights that are above 60 kilograms. For part C, we're talking about a range where we're in between two things. And so not unlike the last one we saw on the first side, we want to find the weights in between 64 and 71. The problem is this time 64 and 71 aren't perfectly on first or second or third standard deviations. And so lower bound will be 64, upper bound will be 71. Again, mean and standard deviation will spit out an answer for us. And what does that answer mean? Well, it means that 36.7% have weights that are in between these two things. All right, well, part D, and again, this is not related to the runner question, but it's asking you to find the proportion of observations from a standard normal distribution that's in between negative 1.51 standard deviations and 0.84 standard deviations. And so, sketch the normal curve. Of course, in this standard normal curve, the mean is going to be 0 with standard deviation of 1. So plus 1, plus 2, plus 3, negative 1, negative 2, negative 3. We're going from negative 1.51 to positive 0.84. And so what percent of this is my distribution? Well, in this case, normal CDF, our lower bound is going to be negative 1.51, upper bound 0.84. This time the mean is 0 and the standard deviation is 1 since it's standard normal. And the result is 70, or I guess 0.734, which means 73.4% of the observations, whatever they are in between these two numbers. All right, for learning target 8, this time you're given the percentile or the proportion, and you're trying to find the actual number. And again, the thing that we're going to use is inverse norm, which you'll find second vars and then number 3 down as inverse norm. And the 3 pieces of information that you're putting the percentile here, 0.45 in this case if we want the 45th percentile. And then we've, again, remember, refer to the runner question. So the mean and the standard deviation are going here. We get 62.497. What does that mean? Well, it means that 45% of the runners weigh 62.5 kilograms or less. Remember, it's percentile, so it's less. Okay, on to the fourth section. Here, you could think of it as the runner question, but because we're talking about z-score, this is standardized, and so it'd probably just be easier to think of it this way. So if it says, 33% of all scores above, well, remember percentile or percent, it's applying everything lower than. So if I want everything above, well, then I would just be going 1 minus the things that are below, and that would give me the things that are above. So 1 minus 0.33 is 0.67. And that's the number that I plug into inverse norm. And I get 0, again, for mean and 1 for standard deviation. I get my answer, and it's 0.4399. Okay, and so on the standard normal table, okay, that value at 33% is going to be at 0.4399. So kind of in between 0 and 1 standard deviations. All right, part C, this is one that we had a chance to look at a couple of times. It says income levels for teachers are relatively normal. If the 25th percentiles, 25% or lower, of teachers make $36,000 annually, and then the 85th percentile, so again that means 85% or lower, makes $52,000 annually, determine the mean and the standard deviation. So we're looking for two variables, mean and standard deviation, which means I want to set up a system of equations. What I'm going to do first is to get those equations, I'm going to realize, all right, well, that z-score formula, the z-score equals my value minus the mean divided by the standard deviation. That's where my equations are going to come from. And I've got a value. I've got 36,000. I've got a value, 52,000. But I'm going to need one other thing in order to solve a system. And so let's find z-score. The way that we can find the z-score is using inverse norm. And so I'm going to put 0.25 here. 25th percentile means 0.25 or lower. And then 0 for the mean and 1 for the standard deviation. It gets me negative 0.674. So that's my z-score with this being the case. And of course, I'll do the same thing over here. So 1.036. And then the 52,000 minus the mean divided by the standard deviation. I do a little bit of algebra manipulation in order to get this equal to something. So I'm basically treating this like my y and this like my x. Again, this is like my y and this is my x. I go ahead and graph that on my graphing calculator, and then I find the intersection point. And so remember that's second calc, and then slide down to number 5, intersect, and then you're going to say first curve, you press enter, it'll switch over automatically to the second line, you press enter, and it'll say guess, you press enter one more time, that'll find you your intersection point, which of course is the solution to your system of equations. And so when we put this all together, your x value is going to be like your mean, your y value is like your sigma, your standard deviation, and so the number that we got, 42,300 for the mean and standard deviation of 9,357. All right, the last question, learning target 9. 20 students were asked to guess the age of Mr. Carlson, and they guessed these numbers here. So you want to know, are these guesses approximately normally distributed? Well, there's a couple of different ways we could do that. If you go ahead and put all of these into list 1, so if you just go to stat, edit, you can throw everything into list 1, and then if you go to stat plot, second y equals, you go to stat plot, and make sure that plot 1 is turned on, but then you can go and you have a number of choices. You could do the histogram, in which case you would get something like this, and you could say, oh, hey, look, that's approximately normal. It's unimodal, it's fairly symmetric with no outliers, and so yeah, you could say that that follows a normal distribution. You could also use this standard normal table, which has 1, 2, 3 standard deviations, -1, -2, -3 standard deviations, then here's all your values on that table. And if this is roughly normal, then you're going to have a linear line. And it's not perfectly linear, but you can see that it is roughly linear, and that is another indication that it is okay to assume this is normally distributed. All right, that's it for Chapter 2.